Hello, Terry Soul here. In a previous video, I showed how to create a swarm of particles that we could control their color and size and have them move around on the screen. The rainbow we see here is one of the things that you can do with a swarm of particles. So it's actually a whole bunch of fairly large dots of different colors moving across the screen, so our swarm of particles. In this video, I want to show some of the other sort of fun things that we can do once we have a swarm of particles to work with. So first, I'm going to walk quickly through the previous code. The idea was we created a class called particles. Each particle is an object of that class. It has its own XY position, its own color, and its own velocity. And then we have a constructor that creates new particles for us, an update that moves the particles around on the screen, and a display that displays the particles. So these are all functions that are part of the class. We can ask a particle to display itself. We can ask a particle to update itself. And then in the main code, we created an array of particles, which we called swarm, happens to be of size 300. We do a little bit of setup, but here's where we construct our new particles, and then in our draw loop, we update and display them. What I want to do here is experiment with some other things that we can do with particles, and I'll start by creating a fireworks display. So if we've got a bunch of particles, you can imagine sort of a firework explosion. And so to do that, I want to change the constructor. I want them all to start again near the center of the screen. So I'm going to change, when we construct a particle, it's going to start at the middle of the screen in terms of the width, and the middle of the screen in terms of the height. And for the velocities, I'll do something similar to what we did in the previous video and have them start based on an angle. So they're all going to head out in different directions. And so if we run this version, you can see they start at the center and work their way out. Doesn't look like fireworks yet, but we'll get there. So a couple of things we can change. One, that's very large for fireworks, so we can make them a lot smaller when they display themselves. There we go. But we also need them to fall down the screen, right? If you want fireworks, they should explode out and then drift down. And that basically involves adding gravity. Turns out gravity is very simple to add because gravity is simply an acceleration that is applied to the velocity. So when we update their position here, we're adding the velocity into the position. Well, to add gravity, we simply have to add an acceleration to the velocity. So y velocity plus equals, and typically it's a fairly small amount. We might have to adjust this a little bit to get it to look good on the screen, but there we'll just add a little bit to the velocity each time, and so that they'll start to fall down the screen. Not too much, but you can see there these started to fall down. So looks like we can do one of two things. We can slow them down initially. So this is our initial velocity here, and perhaps increase the speed that they're falling at. There we go. So now they're falling maybe a little too fast. And the other thing that you'll notice if I run this again, a couple of things that we can fix. They're sort of a perfect ring. We'd like some randomness there. And we have leftover from before a wrapping so that they keep wrapping around the screen. Some nice effects if this is something that you like. So maybe you want to keep the program like this, a Bob Ross style happy little accident. But I do want to go and make this a little more fireworks-like. So first, I'll remove the wrapping effect. Right, these were the lines that allowed to wrap around the screen. And again, I'm going to do it not by deleting that code, because I might want it again later, but just by commenting it out for now. And then the other issue we're having is here where we set the initial velocity. They all have exactly the same velocity, so they move out in a perfect circle. Good for some applications, not what we want for fireworks. So I'm going to create a new variable. I'll just call it velocity. And I want this to be somewhat randomized. So I'll give them a random velocity. And again, we may want to play with this, or you may want to adjust it to get the effect that you want between, say, 0.5 and 1.5. I'll apply that velocity to each particle. So note that because the velocity is being picked randomly in the constructor, when I create particle 0, it gets a random velocity. When I create particle 1, it's going to get a different random velocity. So every particle will start with a slightly randomized velocity. So there, that's starting to look a little bit like fireworks. Of course, they're leaving a trail behind them. And again, maybe falling a little faster than we would like. So I could either increase the initial velocity or effectively decrease gravity. And now we're starting to get a nice fireworks explosion. Maybe even decrease gravity a little more. Something that you can tweak to decide how you want it to go on your own. And of course, now they're leaving a trail behind them, which is fine. But if we want, we can go back into our main program and put the background back in. If we're doing fireworks, those are usually at night, so let's make the background black. And there we go. That's sort of a nice fireworksy effect. You get a circle in the middle because all of them have some velocity. So I would have to make the random velocity include the range 0 to get rid of this little sort of donut in the middle. That's pretty good. We can go a little further here if we want by having them leave a trail behind them. And the trick to doing that is instead of filling in the background with a completely opaque black, 0 in this case, we can instead fill in the background using a rectangle with some transparency. So let me show you what I mean. And the first thing I want to do is paste the background up here in our setup. So that starts with a totally black background. But then I'm going to do a fill whose color is 0, but it has a certain alpha level. So this is going to be all black, but with an alpha, which is transparency, some transparency. And then I'll make a rectangle starting in the upper left-hand corner and the full width and height of the screen. And so now we get that nice trailing effect of fireworks because it's not completely erasing the background. It's simply adding semi-transparent layers of black over it. So we'll run that again. There we go, sort of a nice little fireworks effect. It's getting a rainbow color. So if you're looking at that and saying, well, why is it looking like a rainbow? It's because when we create the particles, their color is based on their number here. So as we go around the circle, they're getting assigned different colors. And we did that in the previous video to get some different effects. For this, we might want, instead of doing it based on the number, to do it completely random. So random 0 to 255. That'll give us completely random particles. Again, probably not great for fireworks, but if that's what you like, that's certainly a way to do it. Alternatively, we could pick a smaller range. So let's say 40 to 60. And what this will do is give us all colors that are similar. So here they're in the yellow and green range. And the way that this works is if we go back here, we're using a hue, saturation, brightness model. So I'm picking a particular hue range. Now the issue with this is I'm always going to get yellow-green. Maybe I want to get colors within a particular range, but I want it to be a different random range each time. And the way to achieve that is to pick a random color here in our main code and pass it to the particles and then have them add a little bit of noise to that. So I'm going to say, I will call this my hue. So I'm creating a new variable hue between 0 and 255. This is going to be an integer, but I've defined, this is going to be a float, but I've defined hue as an integer. So it's giving me an error message. So I'll just cast that as an integer. So a number with no decimal. And now I'm also going to pass the hue into my constructor. And I immediately get an error message because the constructor only expects one argument, but I'm giving it 2. So I have to come over here and say, okay, expect to get a second argument. I'll call it H for hue. And now what I want to do is say, I want my color to be based on that hue plus a random amount. And so in the main part of the code, I basically am picking, if you will, the core color, And then each particle, I'm adding some random noise to that. So here we go. This time I get a bunch of bluish particles, so a blue explosion. Run it again. This time I get a greenish explosion. Here I'm getting mostly red. So each time I'm getting a different set of colors because it is starting with a different random hue. So it's picking a random hue, passing it into the constructor, and then one change I might want to make here, as long as I'm starting with a particular hue, I probably want to do random on either side of that. So -20, for example, to +20. And you can adjust that range if you want to get sort of a more variety. The bigger the range, the more variety you'll get around the center color. And I may also want to go in here and allow my initial random to be 0, and that'll get rid of that donut effect a little bit. Right, there we go. Okay, so the last thing that would be nice is when I run this right now, we get one set of fireworks, they go off the screen, and the program keeps running, but we don't get to see any more fireworks. What I would like is once all the fireworks fall off the screen, or at least after a little while, we get another burst of fireworks. And that's going to be a little tricky. It's going to require some restructuring of the code, because right now it is the constructor that sets that initial position of all of the fireworks. And I need a new function that acts like the constructor, but I can call on existing fireworks. And I think I will just call that reset. So when I start coding it, it'll become a little clearer. So void reset. And then I'm going to use basically the same code as from the constructor. This will be used to reset the position of all of the particles. But unlike the constructor, I can call this reset function whenever I want. So after a little while, after the program has run for a while and the particles have gone off the screen. The other thing that we can do here, because reset copies the constructor, is I can now get rid of this code in the constructor and just say, well, to construct a new particle, really all I want to do is reset it. So if I run this code, it will look the same. Right, so I get the same effect. There's an extra step though. I construct a particle and then I call the reset to actually give it the values that it wants. The advantage to this is now I can call the reset function whenever I want to reset all of them. The way that's going to work is I'm going to come over here in the draw and I'm going to do this a fairly simple way. I'm just going to put in a counter, and when the counter gets high enough, I'll go ahead and reset all of my particles. So let's do that. So first we'll put in a counter, and then for every loop of the draw loop, I'll increase that counter by 1. And now I've got to pick how long before I reset the particles, and I'm not sure. So we'll have to experiment with it a little bit. But let's say if the counter is larger than 300 at a guess, I will first reset it back to 0. So that's just going to reset the counter. But the other thing that I want to do is reset all of my particles. So I'll grab this for loop that I already have, nice and handy here. And instead of displaying the particles, I will reset them all. Reset takes 2 arguments. One is the number of the particle, right? So I have to tell it which number it is. And the other is the hue. And so I want to pick a new random hue. So I'm just, again, going to borrow this code here and pass in that same random hue. And this is, if you're thinking about programming, pretty common, right? I've got a piece of code that picks a random hue for me for creating particles. I'm going to reuse that code here where I reset them. So let's run this and see. So there we get some nice red-orange ones. And at some point, the counter should, there we go, we get a different set of randomly colored particles. So I could maybe up the counter a little bit, but you'll notice that these are not having that nice hue effect. And you might have noticed why already. I made a slight mistake in the code, standard thing to do, make some mistakes. I created a random hue inside the for loop. So for every particle, it's picking a new random hue, and so every particle gets a different random color from anywhere in the spectrum. I need to pick that hue exactly once before the for loop starts. And there we go. I get greenish explosion here. And now I'm getting a nice pink purple one. Getting another green one. Let's see if we can get some variety. There's a blue one. So we're getting different colors of fireworks each time. And from here, of course, there's even more we can do. I think I might move it up the screen a little bit so they start higher on the screen, and maybe set this counter a little bit higher so that we can see them fall a little further. So let's maybe make that counter 500. And then over here where they start, they're starting in the middle of the screen. I'd actually like to start them closer to the top of the screen. There we go. So now we have fireworks exploding from the top. So the key thing to keep in mind in terms of this code is we've taken our particle idea of lots of particles that are moving around on the screen, and what we focused on is just changing how they move to get a completely different effect. So in this case, sort of the key changes, one of the big key changes was just this line right here that adds a gravitational effect by having the y velocity increase with each time step, basically an acceleration. And then some other things that we added that for nice effect was up here, using some transparency to leave little trails behind them. This notion of picking a base color for all of the particles, which we pass in as an argument. And then in the particle code itself, we take that base color, which is H here, and just add a little random noise to it so that we get particles that are all a similar color, but not exactly the same. Again, little tweaks to the program, big impacts on how it looks. I encourage you to play with this code some more yourself. Try, more particles, fewer particles, change the acceleration due to gravity. What else could we change here? We could change the range of the initial random velocities, right? Lots of different variations that you could do. Thank you.